Hello everyone, my name is Akhmetbek. I'm the senior lecturer at the University and also the program coordinator at Computer Science degree. Um, Here's my topic, which we have published on BEEI journal. It's called Recent Developments in the Vehicle Routing Problem under the time uncertainty and also a competency review. Um, so here is the structure of the paper. Uh, we will talk about the introduction, the research method, the taxonomy, about the classification of the paper itself, and also we will talk about the solution methods, conclusion, and also the references of the paper. So, before diving to the paper itself, I want to give some background information about the vehicle routing problem and so on. So here is illustrated the two separate problems. It's called TSP and VRP, where we have on the left side the TSP, the traveling salesman problem, and on the second right side we have the vehicle routing problem itself. So we can call the TSP problem when we have some depot, we have some customers, and that agent, it might be the vehicle, it might be some truck, it might be some buyer, is going, starting his journey, the way, starting from the first customer until the second, third, and so on, serving all these customers, and at the end of the day, going for the depot again. So here you can see that traveling salesman problem will solve the find the optimal way with only one single route. While on the vehicle routing problem, there might be several routes for the one car. For example, we have some car which will serve our customers, like some orders, some demands, and this car will take into his capacity, into his bag, some kind of goods and serve all these customers. Where after serving them, some kind of goods will be reduced from the capacity of the vehicle, and then after the first road finishes, the capacity will be empty and the load of the vehicle itself will be refueled on the depot. And then it starts the second road, the demand will be expiring, and then the third road and so on. So there is the differences between TSP and VRP, where we have single roads for the TSP, and for the VRP we have multiple roads. And also, this VRP could be also, how to say, might be more complicated with adding some new constraints, new features, and so on, which we'll talk about later. So I want to mention that we have the research method. How does we collected our papers? So I have included the keywords for our and the search method for the we took the all data from the Scopus database. We used the search method of the Scopus website, where we have included some specific keywords as vehicle, problem routing, the time, and also the uncertainty. We have been filtered out the year of publishment of the journal, starting from 2005 till 2023. And we also filtered them up, sorted them out with the relevance and picked up top 100 papers, while we also took all these 100 papers, read them by ourselves, and just filtered, took only 54 papers, which are most relevant for this topic, for the time uncertainty, for the vehicle routing problem, with the constraint including the time uncertainty. And here you can see the table itself, only the beginning of the table, where we have collected all these papers. It includes here the first column of the authors, where we have some author's name, and also we have the second column where we are considering some constraint. It might be only single vehicle for the vehicle routing problem, or might be also the multiple vehicles which serves all the customers. And also about solution methods. For example, for the first one, we have the solution methods called MIP or MCSGA. For the uncertainty, we will have, for example, the travel time uncertainty, service time. For the nature, we have the travel time uncertain, which means we have some separate roads, which includes some distances, equal distances, but it might be covering in different times because of traffic congestions, traffic jams, traffic problems, road problems, I mean, and so on. And also another constraint for our problem is time windows. For example, we can have the time windows for time range for each customer. For example, we can have the you can have the time window for the first customer as 8 o'clock till 10 o'clock, while for the second customer we will have from 9 o'clock till 11 o'clock. So the vehicle has to serve these customers within this range. While if you serve these customers uh, not inside, but on the outside of this range, might be before the range or might be being late for this range, they might be penalized somehow. Also, we'll talk about these things later. And you have some, I have included, I mean, we have included some new extra column called extra, where we are like pointing some new, novel, interesting facts about these papers. For example, for the first paper, we mentioned that this paper are including some electric vehicles. They are using the electric vehicles where we have some energy of these vehicles. They are considering there are some battery and so on. Here, for example, we have some uncertain demand, which means each demand could be appeared somehow on some range, on some map, and these kind of things will be hard to manage for the solution methods, for the exact methods, or maybe for the heuristic methods, and so on. And the last one, the last column, is called the benchmark, where we are like taking into account what kind of benchmarks do afters consider. For example, the first after called Hamuti considered only the Solomon benchmark. I think that benchmark is very well like known inside of the community of ecology problem, where we have some radio data set for solving this kind of problem, so on. And also another authors has been considered the series. It might be, for example, city Vienna, on the first or fourth row, or might be on the second row. You can see that the authors considered the China, the city called Shenzhen, and so on. For example, it might be the city Sako district of the some city which collecting some traffic jams, might be some traffic roads, and all these things could be collected on that on that papers could be collected and then made some research according to that series. And here's some visualization for our paper about the distribution of the years of published years. I mean, for example, you can say that only 2 papers are publishing in 2005 and 2006, while on 2020 you can see the maximum published papers related for the uncertain time, uncertain times for the wave correction problem. And also you can say that this kind of problems has been reduced somehow on the next years starting from 2021. And about the taxonomy, which we talked before previously on the previous slides, about the uncertainty of the service time, travel time, and also demand. It might be uncertain service time, which means like, for example, some kind of vehicle will serve some customer, but this serving time could be, for example, 5 minutes, or might be 10 minutes, or even might be 30 minutes, and so on. It also might be distributed with some probabilities, with some kind of, for example, Poisson distribution, might be some normal distribution. These things will be distributed, will be uncertain, and could be somehow problematic for our like solution methods. And also for the travel time, where we have some travel points from A point to B point, these things could be on the first going, like on the first step, it might be faster, and then after some time, it might be like considering too much time from previously, comparing for the previous times and so on. And for the nature, we can again consider the traffic jams. It might be road conditions, the speed of the vehicle. All these things are mentioned on the papers which we have been collected before. And the fleet size of the vehicles, it might be the authors might be considering only one vehicle to serve all the customers, where other authors could be considering many papers. Many papers to serve the customers. And benchmark, it might be again the Solomon, the series, or also after considered about the simulation methods, where they has been generated randomly, or might be some law of the distributions and so on, and solve these problems. And the time constraints, we will have some there might be some no time windows for the customers, or maybe soft time and hard time. Differences between soft and hard. For the soft, if the car will be late or comes before the beginning time range, they will be penalized. While on the hard time windows, when the cars will come late from the end of the range of the time windows, they could earn nothing. They will be just disappearing from the map and so on, just giving reward as 0 for the agents. And here you can see some visualizations for the time windows. We will have some distribution for the hard time windows solved, and also there might be no time windows, and also authors would be mentioned that they have the time windows but didn't consider what type of time windows they have been like generated. And also we have some deadlines, where means we have no beginning time range, but the finishing the last, like the second time range could be existing. And 1.9% of the papers even not like told on their paper what kind of time windows they are considering or not, and so on. The solution methods, the interesting part, the main part, I think, for the wave approaching problem. You can see the distribution of the solution methods. For example, we have been classified the solution methods as like this. There might be heuristic and meta-heuristic methods, mathematical programs, the exact methods, I mean, and also the machine learning basic models and optimization and search techniques. And these things, you can see that most probably people solving the wave approaching problems with time uncertainty use the heuristic and meta-heuristic solution methods. And the second one, the mathematical problem, and the third one is machine learning based models. Conclusion, we just collected the most like relevant to our research topic. It's called like wave approaching problem with some dynamic environments. In our case, we have considered the time uncertainty, and I can probably say that the most like popular, the most like interesting one, the solution method is the old one, I think, is the heuristic and meta-heuristic methods. While we can say that the promising solution methods are the machine learning models, which are like gaining some trend, which are like good performing even comparing for the meta-heuristic methods. But I think that mostly in the future we have to consider the machine learning based models as the primary the state-of-the-art solution methods for this kind of problems with the dynamic things, dynamic constraints, and so on. I think that's it. Thank you for your attention. Thank you for your attention. Feel free to ask any questions from my side and so on. That's it. Goodbye. Thank you for your attention again.